Good morning, dear students. I hope you have gone through the molecular formula and valencies. So now we're going to talk about the first chapter, chemical reaction and chemical equations. And for that, we have to remember the valencies and molecular formula of the chemical compounds. Now let's start. Chemical reaction. What is a chemical reaction? Chemical reaction is a process in which one or more substance, they can be called as a reactant, one or more substance are converted into new substance, or we can say reactant are converted into products, which is known as chemical reaction. So we can define as it is a process in which one or more substance that are reactant are converted into one or more new substance, that means products. So altogether this formation of new substance is known as chemical reactions, and it cannot be reversed by any physical method. And chemical reactions are not reversed from A to B and again from B to A is not being done by physical method, which means you can't get back the reactant by this physical process like filtration, centrifugation, distillation, magnetism, evaporation. This method you might have studied in 9th standard or lower standard. These are physical method, and from this method you can't get the reactant again. So chemical reactions it may involve change in state. It is not necessary every time a chemical reaction occur and solid will change to gases or solid will change to liquid, but sometimes it may there would be a change in state. Means during a chemical reaction physical change in state can occur. A solid can convert it into liquid. Sometimes there is a change in temperature, sometimes there is a change in color, white substance converted to yellow substance. It is not necessary, but it may occur. An evolution of some gases. These are the characteristics of chemical reactions which may occur in a chemical reaction. Now, what are chemical reactions? We have been in our day-to-day life we can see like drying of paint, drying of cement. These are actually chemical reactions. Even digestion of food. When we're digesting food, the proteins are digested into peptides and amines and amino acids. So this is actually chemical reaction. Respiration. During respiration, breakdown of glucose into carbon dioxide and water. This is also a chemical reaction. Rusting of iron. Rusting of iron is also chemical reaction. Formation of curd, like from milk to curd, that is from lactose to lactic acid. All these basic things which we are saying in day-to-day life is actually chemical reaction, and there are so many. You can give me an example in the next lecture. Now, what does it involve? Chemical reaction involve always reactant from the and product. And now, what are reactants? Which take part in chemical reaction? The substance which take part in chemical reaction and due to which new substances are formed. Those substances which are taking part in the chemical reactions are known as reactant. And product, the substance which are formed in a chemical reaction from A to B, the B is product. So those substances which are taking part are known as reactant, and the substances which are formed are known as product. For example, magnesium ribbon. If you burn magnesium ribbon in air, that is oxygen, you will get magnesium oxide, and this reaction is actually you will see is as like a dazzling white flame because of the formation of magnesium oxide. Now magnesium is burning in oxygen, so magnesium and air are reactant. Magnesium and air are reactant. Now they are combining and forming a product, magnesium oxide. So these are reactant and this is a product. Magnesium is Mg and we have to denote as S because we are representing a chemical reaction in terms of symbol. That was the chapter is about, equations. Now when we have to depict a equation in terms of symbol, we have to write whether the compound or whether the substance is solid, liquid or gas. So we will denote as small s in a subscript that we have a solid substance. Oxygen is a gas, so G, and the formation of compound magnesium oxide is solid. So here a chemical reaction is depicted in terms of symbol Mg plus O2. These are reactant. reactant are written on left hand side, and on right hand side there is a product, magnesium oxide, and it is a solid. And this reaction is actually exothermic reaction, which we are going to talk about in the later part of the chapter. What are exothermic reaction, what are endothermic reaction. Now our next topic will be chemical equation, how to write chemical equations. Now let's talk about chemical equations. Chemical reactions can be represented by chemical equations. So when we are talking about any chemical reactions like magnesium ribbon is burning in air, or any other caustic soda reaction with water, so how to depict in terms of equations? So we have to write the symbols along with the physical state. It involves use of symbols of substance, of reactant and product, with the mention of physical state. For example, magnesium ribbon burn in air. So magnesium ribbon will write in terms of magnesium symbol. It burns in air means with oxygen, and it forms a product known as magnesium oxide. So this is actually symbols of reactant sides, and this is of product side. But also we have to mention the physical state, whether they are solid, liquid, gas or aqueous solution. So here I will write magnesium is solid, oxygen is gas, magnesium oxide is solid. Okay, so this is actually representation of an reaction. On for delta sign I will depict as a heat. Magnesium on reaction with oxygen gas, it will form magnesium oxide, and these are the physical state of the reactant and product. So as for solid, L for liquid, which are naturally liquid, like mercury is naturally liquid, water is naturally liquid, they are known, we have to depict as L, G for gas and AQ for aqueous. So sometimes we have to make aqueous solution in water, or the solution in which water is used as solvent. So we'll write AQ. And sometimes the solutions are made in alcohol, so we write alcoholic, ALC. So naturally they are liquid, like water is liquid. So for example, on reaction with water, whenever there is water we will write L. Whenever there is a gases, oxygen, we will write G. Or whenever there is a reaction with gases we will write G. Or when a product is carbon dioxide we will write G. So these are the representation of the physical state. Now dear students, there is a topic called balance equation. This is only a chemical equation. When you talk about balanced chemical equation, let's see. Here there is one magnesium. Here we have one magnesium atom. Here we have O2. There are two oxygen atoms. And here there is only one oxygen atom. So this is actually a unbalanced equation. According to law of conservation of mass, matter cannot be created, cannot be destroyed. Okay, it means the number of atom on the left hand side will always be equal to number of atom on right hand side. It means the number of atoms on reactant side should be equal to number of atoms on the right hand side. If there is only one magnesium, there should be one magnesium. If there are two oxygen, there should be two oxygen. So by this way we can follow the law of conservation of mass. Mass cannot be destroyed, means magnesium, if you are adding in the reactant side, there should be one magnesium. If you are adding two, there must be two on the right hand side. Now let's talk about balance equation. How to balance a chemical equation. We'll see one example and then we'll talk about in detail how to balance the equation. Let's talk about balance equation. How to balance chemical equation. So first of all, I take an example of like magnesium plus O2 gives MgO. First of all, we must write the reactants and product. Reactant and product. Magnesium, we have one atom on reactant side. We have atom. Oxygen we have 2, we have 1, and just nothing else. Only magnesium and oxygen we have. Now we can see on reactant side there is only 1 magnesium, on product side we have 1, oxygen we have 2, 1. Now just put a bracket here. It means we can't change the number of atom inside the bracket. We can only change outside. It means there are 1 and 1 means it is already balanced. Magnesium are balanced, we no need to change. Oxygen we have 2 on reactant side and 1 on product side. Now we can multiply by 2. So we'll have 2. So here reactant side we have 2, on product side we have 1. So what I will do, I will write 2 in front of, I can't change here. I have to write compulsory here just before the bracket. Now on the reactant side it get 2, but while balancing oxygen, magnesium got unbalanced. Here this 2 is for both. While balancing oxygen, I have put 2 over here, but magnesium also get 2. Now again I have to multiply by 2 here on reactant side. So while balancing here, this also get 2. So this is way we can, this is called heat and try method. Let's take another example. Fe plus H2O gives Fe3O4 plus hydrogen gas. Okay, now let's depict as in terms of symbol. Here iron or ferric is as, water is liquid, this is reddish brown solid, and this is gas. So we have equation, iron reacts with water, actually steam, or we can say it at high temperature it becomes steam, so we can depict it as a steam. If we take, this is ferric oxide, or we can say iron, red iron, and hydrogen gas. So here we have reactant side, product side, Fe, hydrogen, oxygen. Only 3 elements we have. Now write down the number of atom. Here we have 1, on product side we have 3, hydrogen we have 2, product side we have 2, oxygen we have 1, oxygen we have 4. Now as I told you, just make a bracket. So just to understand that we can't change the numbers inside. Okay, we can only change outside number. Now we have 1 Fe, we have 3 Fe. So what we can do, we can multiply by 3 on reactant side. So I will write 3. So both get balanced, 3 Fe, 3 Fe. Now hydrogen is 2 on both sides, 2, 2. It means already balanced. Oxygen we have 1 and oxygen we have 4. So what we can do, we have to make it equal. So I will write into 4. Now I have put 4 here. But as soon as I have put 4 at reactant side, my hydrogen got unbalanced. 4 2s are 8. Now it becomes 8. So I have to again change the hydrogen here, and to make it 8, I will write 4. So in this way, we can balance a chemical equation. This was about the simple. We'll talk about another examples. So this was about how to balance a chemical equations. That's it.